Good morning, everyone. Thank you for your patience this morning while we were setting up. My name is Deepak Lal, and I'm the Managing Director of Qualitech. So we thank you for taking your morning to spend time with us and learn about corrosion. We have Mr. Josh Tankersley, who is from Corrocoat, USA. He heads the entire operation there. And basically, we are very fortunate to have him here with us to share his expansive knowledge on corrosion issues all across the world. Josh will speak more about where Corrocoat is located and what they do. What is a very in-depth research facility that they have in the UK, and they solve some of the most challenging problems. So as we go more into it, we being the licensee and not necessarily a distributor, there's a difference. When you distribute a product, you just sign an arrangement, maybe do a couple of days training, and then you distribute product. But we are not a licensee, meaning we actually pay for representing Corrocoat. Training that Cindy and Ramphal at the back, who is our NACE Level 1 in-house inspector, they would have spent 3 weeks in the UK learning about the product, and not only learning about it academically, but also applying it themselves. And when they apply it, it also has to be tested. So the training, passing the training, means that they would have successfully learned, applied, and test what they applied in order to get the certification. So it's a really, really in-depth process. And if you don't go through this, you cannot apply Corrocoat, basically. So I just wanted to pass you over to Josh, and yeah, hope you have a good session, and over to you.
I have one.
Okay.
Yep. Thank you all. Yeah, so we've already started talking, but I'm Josh Tankersley, Corrocoat USA. I'm the director of Corrocoat USA. I've been there for 16 years. Practically started the office, and then we've moved into where we have a fully functioning, successful business there. As Deepak said, recently we were fortunate enough to have a deal with them to be a licensee for Trinidad, and then also the Caribbean, and an option on Guyana as well. So we're really excited to be here. Glad to start doing work in this potentially very fruitful country. I know you have a lot of corrosion, a lot of industrial business, and it's nice to be here. So thank you. Presentation contents. We're going to start by just kind of giving you an introduction to Corrocoat, talk about our technology, what we do, what differentiates us. We'll go through a summary of some of the Corrocoat products. We have over 80 products. I'm not going to go line by line and read each data sheet, I promise. They are available online and as requested. Then we're going to go through with some potentially relevant applications. It's going to kind of be a show and tell. I ad-lib a little bit. We may have a story or two. As we go, we are an intimate group. Please feel free to ask questions. We will have a Q&A at the end. But if you think of something, raise your hand, and it's meant to be a discussion. Okay? So Corrocoat. We exist to engineer corrosion-resistant coating solutions for aggressive service environments. A variety of substrates: pipes, pumps, concrete, tanks, tank linings, the internals, the externals, fiberglass repair. We specialize in the difficult applications. We will do the easy stuff as well, but typically we start with someone saying, here, this is my most difficult problem. Can you help me solve it? We're glad to do that. In the U.S., here's just a snapshot of some of our customers in the U.S. I'd say about 50% of our business is in energy, whether that's power generation or oil and gas. We do also do petrochemical, marine, some food and beverage, and then there's always oddball inquiries. We do some wastewater. Wherever there's corrosion and it's aggressive enough to warrant the investment to do it right and make something last a long time, or sometimes maybe it won't be as corrosive and access is a problem. Equally, if it costs a lot of money to access something, you don't want to have to do it again. So the Corrocoat business model, it flows right along with Qualitech to where we can be a single source solution. Qualitech as a licensee are able to apply the product as well as specify and supply it. So Corrocoat operates to where if you have a problem, you contact Cindy, you contact Qualitech. She's going to understand the problem almost like a doctor would. We're going to ask you questions to diagnose what it is needs to be done. If we have a solution to that, then we'll supply the product and apply it. It's a single source solution. Now that's counter to what you're used to, where you have one company supplying the product, and then another, you put it in the spec, put it out for bid, and then other contractors provide services. 9 times out of 10, that works perfectly fine. It's that 1 time out of 10 when there's a problem, who's responsible? So we take full responsibility, and we take pride in that. Now, for that reason, we're not going, if you have an inquiry that is on the edge or unachievable, we're going to tell you no. If it's on the edge, we might say, it might work. We'll test it with you. But we're going to be honest. I mean, it takes an extreme amount of integrity to maintain integrity. Corrocoat. We operate out of the UK. So in the UK, in Leeds, England, we were founded 51 years ago. Since that time, we've expanded all over the world. This is the 3rd time I've given this presentation. I still don't have Trinidad on there. Trinidad is our newest licensee. So now we have 2 dots in the Western Hemisphere. Nice to have some company. We manufacture in 5 locations. In the head office in the UK, in the US, India, Kazakhstan, and Japan. So I could also put this do it right the second time, because people usually don't get it right the first time. But when you have a corrosion problem, it's important to understand where the costs really are. Generally, it's not in the bucket, despite your paint salesman saying, I've got a product that works and it's 5% less expensive. Well, based on my experience, being a turnkey solution, as the contractor as well and the manufacturer, the cost of the project, the cost of the coating in the project is only about 5%. Where most of the cost is downtime, it's engineering, it's access. I mean, you see a guy here, he's in a scaffolding in an outlet duct, which is 175 feet off the ground, abrasive blasting. That's where the cost is. It's highly dangerous work to be able to do the correct surface preparation for pretty much any coating that you're going to apply. So if you're going to go through all of that trouble, it's good to get the spec right. It's good to make sure that you're dealing with a partner who's going to take full responsibility. So Corrocoat, we operate naturally on the Pareto principle. I'd say about 80% of our specs end up being glass-flake vinyl ester. That's when we're looking at internal linings. The vinyl ester resin, particularly Novolac vinyl ester resins, have an extreme temperature resistance and chemical resistance. That stated, we also make polyester-based resin-based coatings, also glass-flake reinforced, a variety of different types of epoxy resin-based coatings, specialty coatings, and including surface-tolerant primers to where maybe blasting isn't feasible. So we can do a lot of things with our technology and experience. We have an in-house R&D that continue to work. We have a full-time staff and some really expensive equipment in England to where we're always improving our existing coatings and then also creating new coatings as new technology comes out in the resin systems and then in different additives, in addition to a response to the marketplace. We can make a custom coating to fit your need. It just needs to be something that we feel like is going to be commercially viable elsewhere. So if something really, really cool comes up, please let us know. That's what keeps me going. We may or may not be able to cater to that. So corrosion, as you know, it's a reaction between 2 substances. Steel and concrete, they're at the forefront of the human condition. We have a huge technological society, and a lot of that is based literally on concrete and steel. These are man-made items, and there's a natural tendency towards equilibrium. It's inevitable that they're going to corrode. They're going to find a balance, and then you're going to see rust, and you're going to see pitting, and you're going to have to either replace something or protect it. We look to protect it. Practically, as you can see here on the picture here, whenever you're looking at fabric maintenance or internal linings, over time you may see permeation through the given coating film, which will allow moisture or other corrosion causing ions to get through the film and to the substrate. It starts to corrode, you get a bubble. Now the reason that happens is because you have a tendency towards permeation. When you have a film in between differential pressures, gas is going to want to try to fill that void. That's the natural phenomenon that we're fighting. We do that. Corrocoat is based on glass-flake technology. So in the early 50s, the founder of Corrocoat, while he was still working his regular job, started tinkering around with resins and glass flakes in his garage until he found a formulation that he liked. The idea is that if you put glass flakes in a coating and you load them correctly and you put other additives and fillers to ensure that you get the viscosity right, you can make a situation to where the corrosion-causing ions go into a tortuous path. These are actually free film samples of coating, but they work here as well. So imagine if these were glass flakes, 3 microns by 100 microns, so 3 microns thick by 100 microns diameter. For reference, the average human hair is about 70 microns diameter. So we're talking about really small chemistry or physical properties. They line up like this within the film. This is about 1 millimeter. You can do the math on the 3 micron. You're going to get about, 25 layers, including the resin in there. Within that layer, then you've created a situation to where you lose momentum, and now you have a liquid-applied barrier coating. Without the glass flakes or something that has a shape and something that will line up like that, you have to put more coating on to get the same resistance to permeation. There are some coatings and resins that are highly functional, but it never works out as well as whenever you use glass flake. As we'll talk about earlier, sometimes we do have certain situations where glass is not the best flake to put in, and we have substitute flakes. So obviously it doesn't line up just like the cartoon, if only. When we first started in the 70s, we used glass flake that was a byproduct from Owens Corning. So they basically classified their waste. You melt it down, you inject the molten glass with air, it explodes, you have bubbles, then you classify again to get the different sizes you put your glass flake. It's a crude method for making glass flake, and it leaves you with a wide variance, 3 to 20 microns thick. It still works. There still are, we have a lot of competitors that still use this type of glass flake. It works to a certain extent. In the early 80s, however, we became dissatisfied. We wanted to continue to get better. We're always looking to improve. So we started an R&D project. The owner said, yeah, I think I can do this better. So he developed a method that makes glass flakes utilizing molten glass that are poured down onto a spinning table. You vary the size and the thickness and the consistency of those glass flakes by varying the speed, the centripetal force. Now you can get glass flakes that are 1.5 to 3 microns thick. That's what we use for protective coatings. We've even gotten to where we can make glass flakes that are sub-micron, and those glass flakes are sold into the cosmetics industry. Some of you ladies may be wearing them today. The glass flake industry has really, that subsidiary and that sister company has really taken off on its own direction. We sell glass flakes into the market. We've merged with the inferior glass flakes. We're one of the top 2 companies in the world that manage the glass flake industry because it's so vital to our business for protective coatings. Now, we don't just go out to the beach with a shovel and a bucket and get some sand and then pour it in and melt it up to make our glass flake. It's silica, essentially. We have a proprietary list of ingredients. These are ranges, of course. I wouldn't give you the full formula. I don't know it. So that we have extra corrosion resistant glass flake. The idea is in heavy chemical environments, it's not good enough to only be able to have that tortuous path with water. You also want to have a glass flake and resin systems that will resist and are inert to a wide range of chemicals. So the glass flake is the backbone of these coatings. The resin selection varies depending on the temperature and the chemicals and the service, but having that effective glass flake loading is what really, really makes us different. We don't just pour the glass flake into a vat, spin it around and say, yeah, that's good. We do extensive testing when we're creating coatings and when we're testing against different service, sometimes to prove to ourselves, sometimes to prove to customers. So these are 4 of about 2 dozen tests. So we'll do the cold wall test. Has anybody heard of the cold wall test? An Atlas cell test? No. The cold wall test utilizes coated plates and a translucent tube. The beauty of this, particularly when you're testing for high pressure or high temperature and chemical, is you can put a given chemical in there. You can put the exact same chemical in there to mimic the environment, alter the pressure and alter the temperature to ensure that you can handle that. Now, we don't only do that for the operating environment. Most customers will want us to do that test for the maximum operating temperature or in upset conditions. We will test it to failure in some cases because you want to know how far the coating will go. Whenever you're looking at separation vessels and process vessels, you want to know the limit because these are really, really important vessels to a process. That $100,000 tank lining is a drop in the bucket compared to the downtime for some of these things. Cathodic disbondment testing. This tests the electrical insulation value of the coating. The coatings are insulative. At 40 mils, this product, Polyglass VEF, is resistant at 25 kV, so 25,000 volts. The idea is if you know how resistant something is to electricity, then you'll know how corrosion resistant it is. We like this test, and it's one of the first tests when we're testing coatings for efficacy because you can have a quick feedback loop. Yeah, you don't have to wait 6 months like this test. You can go through and fine-tune that this mixture works better than that mixture. Flexibility testing. Now, different materials, different resin systems, different glass flakes and loading have variations of flexibility. When you have a tank or a storage tank and in different areas, you want to at least have the coating to be as flexible as the steel. We can't do anything about steel that bends like this. Corrosion isn't your problem at that point. But we do understand that at varying thicknesses of coating, we have variable flexibility. It's not just about flexibility, it's about endurance. So when you have a tank at the floor-to-wall interface, particularly, when you empty it and fill it, you're going to have a variation of flexibility. And over time, it will start to bend, almost like a paper clip. You know, you have a paper clip and you start to bend it, eventually it's going to break. So we created this apparatus so that we could understand at given thicknesses how much flexibility. At 1 millimeter, the VEF will go over 1 million cycles. At 2 millimeters, you're at about 250,000 cycles. At 3 millimeters, 1 cycle. So, you know, there's mutually exclusive properties with some coatings, such that if they're highly functional and they have permeation resistance, they may not have as much flexibility and vice versa. You want to find that sweet spot for the given inquiry. And then, of course, permeability testing. So this test uses a free film sample, kind of like this. You put water in here, you have variable pressures and time, and then you monitor how much water is lost. It's a relatively simple test, but it's standard. ASTM D1653, for those of you, if you want to AI it later. We've seen, one of the tests, as you say, is the product with the glass flake much better than that resin system in fiberglass. So we'll do that. You know, you want to good science only changes one variable, and then you monitor the results. We're a full magnitude less than a lot of the competing glass flake coatings, and even more less as far as permeation than fiberglass. I'm not going to go through all of the other lab tests, but we do have a sister company called Core Labs. If you have an interesting corrosion problem, Qualitech has access to them as well. We have done lab testing for a fee. It's not our primary mode of business, but there are costs to consider. So we can be very cost effective with those sort of lab tests. We're not going to be like the engineering house who charges $1,000 a page. So just keep that in mind. Sometimes we will do that as an additional service. Everybody doesn't take our word for it. Sometimes they want third-party testing. We're happy to do that. If you want to do comparative testing, if you have the money, we're happy to do that as well. I've done very well in comparative testing over the years against all of the big boys, all of the names that you may have heard of. All right, so Corrocoat specialty coatings. We talked a little bit about the VE, and I told you about the Pareto principle. We spec it a lot, so bear with me. pH 1 to 13 up to 230F. We're going to talk about Corrothane XT in a minute as well. I have some slides dedicated to these. Corrothane XT is a high temperature version of the VEF. It's a vinyl ester urethane copolymer. That'll get up to, and let me talk and see, 150 C immersed and 500, that's 300 C non-immersed. We have the AR4. So the Novolac vinyl ester is really good. It uses cobalt as a promoter. The problem with cobalt is in high pH situations, the cobalt can be attacked. So we will substitute the brominated vinyl ester, the Corglass AR4, in those situations. I think we're doing a project with AR4 coming up at Promont. The downside to the AR4 and the bromine, the reason why we don't use it on everything as a promoter, is it's not as good of a promoter as the cobalt. So you have to add heat to get a full cure. Still, it is the best solution around. We can handle fully saturated concentrations of sodium hypo, sodium hydroxide, all of the good stuff whenever you're looking at caustics. I mean, I guess alum would be the only other one that you would ever see. Corrocoat E-Series. I don't know if you have any pumps or impellers that are dealing with cavitation issues. I mean, as you know, cavitation, it's the small bubbles that are caused by design flaws. They explode on the surface. We can contain the cavitation. We're not going to be able to stop it, but we do it better than others. So if you have cavitation problems, we have an app for that as well. And then biofoul. All of you are inland. Do you have any situations where you're dealing with fouling and you're looking for anti-fouling, maybe for your cooling water systems or firewater piping? Yeah? Yeah, so the biofoul is a polyester resin-based coating that utilizes elemental copper flake. The copper emits ions, which the biological growth will not adhere to. So it's not like your traditional anti-foulant, which is ablative, which has multiple colors and multiple coats, and the fouling just peel it off. And then you get to green and you say, I need to coat again. This is a fully functional, long-lasting barrier coating. So some of the epoxy coatings, Plasmid ZF, this is our surface-tolerant epoxy coating. It utilizes glass-flake and micaceous iron oxide. You know, you fight rust with rust in that situation. And then other proprietary components which help increase the passivation of the surface as well as make it surface tolerant. We've been fortunate enough, and I have other slides, of course, so I don't want to duplicate too much. About 7 years ago, one of the big players in the oil and gas world asked us to put this product, Plasmid ZF, in an aerosol can. We're able to do that. Give it a little cliffhanger. We'll talk more about it in a little while. Plasmid AR3, which you're using at Promont as well. The AR3 is 98% sulfuric acid resistant. That's for full immersion or for secondary containments. In general industry, I see a lot of inquiries for secondary containments or maybe U-drains, which are particularly nasty and fun to deal with. We have the Zip E. So So you see a picture here. This is a project that we did 8 or 9 years ago in South Carolina. So on the bridge going to Hilton Head, South Carolina, there are 2 transmission poles like this. One of them, they had too deep, so it's in the tidal zone. So in tropical waters, zinc, which is galvanized, so zinc will be consumed at a faster rate. Works great in Massachusetts or in England, but whenever it gets hot, it doesn't last that long in immersion conditions. So they were losing steel, and it was a big problem. They asked us if we could pull a rabbit out of the hat and deal with it. We had to wait until the king tide in October. Even then, we only had 45 minutes per day to deal with it. So it took 3 days. We had to have a team on a barge, wait till the tide went down, go under a bridge from the dock. Tide went up, tide went back down. So it was a long day on the barge to do 45 minutes worth of work. Scrape the barnacles off. We used an inert abrasive and vapor blasting techniques to blast. We put a coat of the Zip-E. We altered that batch of Zip-E so that it would kick off quicker. So it polymerized. We were not able to get the second coat on that day. So the tide went back up. We went back through again. Even though it had been in water, it was still in its active phase of polymerization. So we wiped it down, put 2 more coats on, still fine. It's perfect. So, I mean, these are the type of mission impossibles that Corrocoat thrives in. Application characteristics. So it's more than just the glass flake, and it's more than just the physical properties and the chemical properties of the resins. You also want to understand application characteristics. Gel time, pot life, just a few vocabulary words. So pot life or gel time, that's the time it takes between when you mix the part A and the part B for it to go from a liquid to a solid. Shelf life, generally that's pretty static for us. So the vinyl esters are getting 6 months. The polyesters are getting a year. The epoxy coatings are stated at 2 years, but we've seen them last much, much, much longer. Viscosity, so I have a couple pictures here to illustrate viscosity. One of the levers that we can pull whenever we're making coatings to make them effective for the given use is viscosity. So the same chemistry and the same service, the same resistance, but in 2 different thicknesses. So in certain cases, like whenever you're looking at a cove base or when you're trying to fill pits, you want something that's thick and can be trowel applied. In this case, they're using a little Bondo knife. And then in other cases, we have a blind vein on a pump. You want it to be so thin that it's pourable. We were able to rig up a caulking gun, essentially, to pump. We mixed it up and we were able to pump the coating in so that it drained out in this blind vein. You move it around. You look at it with a mirror. You literally rinse and repeat. The idea is that we can pull those levers to make given variations of the same coating so that it's effective to use. Hold up, that's whenever you're spraying or brushing. How much will it hold up? What's the thickness that it's going to hold up vertically? We have coatings that will hold up at 40 mils or 1 millimeter before they start to sag. In certain temperatures, we can go much higher than that even. And then overcoating window. So overcoating window is particularly important, and it's something that we understand as a coating manufacturer and applicator. Overcoating window is related to the polymerization rate of the coating. At higher temperatures, that polymerization rate increases, which thereby the overcoating window decreases. The overcoating window is essentially when you put one coat on, how long do you have to put the next coat on, and then cross-polymerize. So you have a chemical bond between. If you miss that overcoating window, you don't have to start over. You typically will just have to sweep blast and get a new profile onto the surface, which can be expensive. It's not ideal. It's not the end of the world, but it does cost more. So when we plan projects for given coatings, we want to understand their overcoating window so that sometimes you may have to work odd shifts, you may have to have 2 shifts, or you may just resolve, I'm going to put a coat on and then I'm going to miss it and then I'm going to sweep blast. understanding the whole process is important, particularly whenever you're dealing with this sort of stuff, so that you can have a project from start to finish that lasts and works and doesn't cost an arm and a leg. I'm not going to go through every one, but pretty much every one of our coatings, we can make a system like this. So this is a cross-section of a tank floor. This will be all the same resin system. We have a laminate where we can use fiberglass laminate here at the tank floor-to-wall interface. It's a standard spec to increase flexibility and endurance. You have the filler material. We're filling in the pits. We're also filling the cove base like you just saw. And then you have top coats. So within the VEF and the VE systems, we have primers. We have a standard VE, polyglass VE, which can be spray applied or hand applied. We have the VEF, which hangs at 40 mils. If you're doing a big tank, if it hangs more, it's going to be easier. It's going to cost less. We have the hand applied version. We have a VFWR that's wear resistant. If you're dealing with slurry or some abrasion resistant, that utilizes silicon carbide and calcined alumina to increase the abrasion resistance. Different primers, laminating resins, pipe grade. Like I said, we can take this basic model and then give you different options. We do a lot of tank linings. This is a slurry tank. It would have utilized the VFWR. You see a portion of it coated here. Generally, when you're doing a tank lining, you work top down. It's essentially two projects. You have to build scaffolding, you have to have access to the roof and the floor. You suck all the grit out, and then you go in and do the floor. And you either maintain the overcoating window at the interface, or you resolve to sweep blast onto that so that you get a good bond in between the top and the bottom section. We supplied coating for this system. We prefer turnkey, but in certain situations, there's nested contractors to where it makes sense for us to just supply the coating and or supply support. So, if you're offshore and it's a relatively straightforward application, that might be the way. You buy the buckets, and ideally, you may want to get some support as well from Qualitech. But yeah, this is a 280-foot diameter crude oil storage tank. 2 40-foot containers full, so about 8,000 gallons worth of coating. A lot of coating. This is just a cool picture. It's a process tank that we did. Whenever we're looking at process tanks, it's important to understand the sequencing. So if I ask you for an inquiry on a process tank, I want more than just it has hydrogen peroxide and it's dosed with hydrochloric acid at 10%. I do need that information, but I also need to know the sequencing and also what the base is. I want to understand if we're going to worry about exothermic reactions that may or may not be beyond the temperature resistance of the coating. I want to understand whether or not what you're dosing in there is miscible with the solution. If it's not miscible, then you may have a hot spot. If you put 20% hydrogen peroxide into a tank, but you're only putting 1% of it, that's not a very high concentration. The coating will handle it. If it's not miscible in the tank and it falls to the bottom, now that might be beyond the chemical resistance of the coating. These little details can be the difference in a successful project or one that is a really big problem for everybody involved. Corrocoat XT. There we go. I've got C on here. 150C, 260C. So the Corrocoat XT works a little differently. You actually have to mix it. It's a step-down mix. So you mix in the urethane and the urethane diisocyanate, which will catalyze the urethane. You let that sit, and then you mix in the MEKP, the organic peroxide, which catalyzes the vinyl ester. You step that and you time it. The idea is you get a thixotrope of each material, the urethane and the vinyl ester, and they wrap around each other like two ropes or like two snakes mating. The idea is you have this double thixotrope that are wrapped around like a really sturdy rope. Whenever the temperature rises, those thixotropes expand and they actually close the gap, so you have an even better moisture vapor transmission resistance. That's the difference in this product and the standard vinyl ester. And this is a product that will succeed where a lot of other coatings can't. We'll use this in ion exchange vessels that are high temperature. Test separators, you know, a lot of times the VE will work fine in the production separators, but the test separators where you're going to see a higher temperature, it works well there. For CUI, you want to specify, CUI is corrosion under insulation. You want to specify for the immersion conditions, not the non-immersion conditions. If you're having CUI, it's because you have moisture on the surface. That's a common problem with specifying corrosion under insulation. Excuse me. Is you look at the wrong number. So this is a specialty coating. This is the type of coating that only Qualitech would be able to apply. Certain applications and coatings, we're not going to sell in a bucket and give you support. We're going to say we're going to do it all. It's our reputation on the line, or we're not going to do it. Different types of tanks and vessels. Do y'all have tank and vessel linings that you deal with, or is it mostly fabric maintenance? Some, yeah. Water filters, you know, you get abrasion in certain situations. Armagel is just an earlier evolution of the VFWR. I actually like the name better, but as you move along, you know, you create new names. Isotainers. This is a hydrochloric acid isotainer. This also works well with frac tanks or produce water tanks, some other bad actors that you may be dealing with. Tank linings. This is a good picture of a slurry tank. You see how he's spraying that. Whenever we're doing these tank linings, we're going to give him supplied air. He chose to use a blast hood because it has an air condition, but there's other ways to give supplied air. You can see this flange here, it's finished flat. We have a better method of dealing with a flange, but in situ, on a big flange like this works pretty well. So you see we'll fiberglass it out. We make free film samples with the coating. We use those as shims. We essentially glue them to the substrate here. Then we clamp down a piece of laminar board. Wait about 4 hours, you pull it off, and then you get a flat flange. It's much more effective. It leaves a flat finish, plus or minus 0.005. Easy to go onto, particularly with a soft gasket, and it's done. In other situations, I've seen us before we started doing this, and then others, they spend as much time on the flange faces as they do on the whole tank. So you want to be able to have effective methods like this. Now, do you have any flanges that look like this? Crevice corrosion, it's pretty prevalent. It's the small areas that cause us the biggest problem, it seems like. We deal with that with a spec, I don't know if you've seen it, to where we recommend that you rebate the flange down 60 thousandths on the ID. That works great. You fill it with coating. The coatings are fully machinable. You can put it on a lathe if that's possible to machine it, but you don't really have to. We're able to get plus or minus 5 thousandths, which is the BP spec, right here, no problem without machining. Some of the more abrasion-resistant coatings are only machinable with a diamond tip. So, I mean, whenever this is some polymer chemistry that has really, really good cross-dimensional stability, and it's very, very hard. In situations where you're really in trouble and maybe you spec the wrong metallurgy, you may need to be able to do something in situ. This is a project that I went out to help out with this summer in the Gulf of America. This is something where we used a casting method. I brought the 1.5 inch because it was easier to fit in the bag, where we fabricate with our machine shop, and Qualitech can do the same, flange formers to spec. So this is a 300-pound flange, raised face, with 125 RMS finish. We sent those offshore. We sent a crew offshore with coating, the plasma and HT coating. You paint this with a bond release agent. You blast the coating, or you blast the surface of the flange. I mean, these flanges were eaten up. They were losing seals. It was a major problem. Fill in the pits, prime it, bolt this to the surface, like you can see my colleague here. Leave it, you torque it down, leave it on in place for 4 to 6 hours, pull it off, finish it, and you're done. We did 94 flanges in 9 working days. The competing solution was going to be 48 flanges in 16 working days. They were on a 12,000 barrel a day deferral for the project. So significant savings using Corrocoat as opposed to the competing method. We can do really cool things. This looks like Swiss cheese whenever it's blasted, as you see. We can use composites to refurbish that, bring it back to life, fully pressure tested at 1.5x. You might think, why would you even do anything with that? Let's just throw it in the scrap pile. Sometimes you don't have the time to do that. You need a quick turnaround. Even if you did have a spare and you're in an emergency, if you have something that's seemingly scrap, call Qualitech. They may be able to take that off your hands, refurbish it for a fee, and then now you have a fully refurbished corrosion-resistant scrap for when the other one failed. I've even seen business models in Corrocoat to where we've bought scrap materials, pumps and pieces like this from customers, refurbished it, and then sold it on the open market. It's a really, really good utilization for Corrocoat and Qualitech for you to make the most of what you have. I mean, it's a waste not, want not philosophy. We can use cold welds. So this is a project that we did 90 feet up at a pulp and paper mill in a bleaching tower. So the bleaching tower had 10% sodium hypo at 180 degrees F, which is 80 C. It was a tile line tank. The tile failed, and they had a gaping hole here up at the top. They had a short outage. They had other work going on in the area. They couldn't do hot work, like a lot of your plants don't like hot work. So we were able to prefabricate a free film sample to the curvature of the tank, coated it on the back end. We vapor blasted, primed the surface with the coating, and then essentially glued it in with our coatings. As you can see, the finished product is going to last longer than the tank. They're never going to have to worry about that again. Pipe wrapping. So we can do a similar situation with fiberglass and with our composite materials with pipe wrapping. I'm sure you've done pipe wrapping with other materials. Is that right? You buy them on the open market. It's not something that Corrocoat invented. We can just do it very well. We have an ISO certified process with this pipe wrapping. It's ISO certified based on a training regime which Ramphal and Cindy went through when they did their 3 weeks training in January. It gives you a little extra assurance. The first part is we analyze the problem, and then we will work with an engineer to do an FEA and do a design requirement. We get that stamped design, and then we go execute it using our CSR materials. CSR for composite structural rehabilitation. There's a really good video online that indicates how we can do that, how we can deal with through-wall corrosion, and then pressure tested at plus 250 bar, even at a 25 millimeter deal. So there's different classes when you're looking at the ISO. You've got the low spec duty, static head, drains, cooling medium. Class 2 might be fire water and deluge systems. And then you've got your hydrocarbons, flammables, and class 3. We don't just go out with some fiberglass and resin and wrap your pipe real quick. We could, but that's not what you want. You want to have something to where you have a quality assurance and you have reliability, so it's a process. This is something that Qualitech can spec, and then they can also stock, and then it's just a matter of having relationships with engineers to have a turnaround very quick. So just keep us in mind whenever you do have problems on your pipes and you need to do pipe wrapping. It can really, really get you out of a jam. Here's a picture of some pipe wrapping in the lab. The designs vary depending on the situation. But you have multiple layers of laminate, then you sandwich it with coating, so on and so forth. It ends up looking like a Big Mac that you wouldn't want to eat, but it'll work really well whenever you're looking at reducing corrosion. Tube sheets. Oh, yes, go ahead.
Thanks. Just want to find out if the pipe racks can be used for online leak sealing, or is that specific to FRP piping only?
No, it would be for steel piping as well, but it does need to be out of service.
Okay, thanks.
Tube sheets, in certain industries, you metal up for your tube sheets. Still, sometimes the metallurgy doesn't work and you need to coat it. We can do tube sheets. It's a young man's game because it requires very small plugs, so arthritis doesn't work very well. We do have young men at Qualitech and women. We can do these projects as needed. We specify according to the service that you're looking for. So water boxes, heat exchangers, tube sheets, channel heads. For some reason, this piece of equipment has many names across different industries and across the world. We can use refurbishment techniques on cooling water lids like this, water box lids. You can see it's eaten out. This is one of our main customers in the U.S., a power plant. I mean, before we were out there, we're a nested contractor out there. We have full-time presence. They were just throwing these away. No more. We can do that refurbishment in a matter of about 3 days comfortably. If they needed it quicker, we could probably get it done in 36 hours. Pump linings and pump refurbishments. Qualitech are specialists in pumps. They supply pumps. They refurbish pumps. This is really a sweet spot for this operation. When you use coatings to refurbish pumps, one, you reduce the friction based on filling pits and having a higher functioning pump. And then we have top coats called Fluiglide and Fluiglide E, which are hydrophobic, kind of like Rain-X that you put on your windshield, and they reduce the friction. When you utilize those top coats, you can have an increased efficiency even from a new pump. And the idea is that you have less energy input to get the same output. On a pump that's big enough, the project can pay for itself in a matter of weeks with the savings of energy. So this is a situation to where the accounting department actually will like, and the production department will like, and it's not as much of a maintenance issue if you have the right perspective. This is a picture of one of 6 pumps that we did for NASA. These are cast pumps, and it was going to be an 8-month lead time. So NASA said we need it done pretty quick. We've neglected these things. They just sit in salt water. These pumps are used to flood the launch pad after a rocket takes off. The size of these, it's about to scale. I mean, you can stick your thumb in these pits. I mean, it was really eaten up. We're able to use our materials to fill the pits and line it and put the hydrophobic top coat on so that now you have a fully refurbished pump in a fraction of the time and in a fraction of the cost. You can even use your materials to cast. We use the shaft to cast the bearing edges. There's a lot of really cool stuff that we can do with our materials. We're much more than just coaters or painters. Pipelining. Is pipelining something that maybe interests? Do you have internal pipe corrosion? Yeah, maybe some, yeah. We do a lot of pipelining, particularly for the oil and gas industry. It's not cheap. We're in Florida, and a lot of the oil and gas industry work happens in Louisiana. Despite that 9-hour drive, they're fabbing in Louisiana, shipping their pipes to Corrocoat, USA. We reline them and ship them back. The reason is in a service and produced water service for given owners where they're getting 18 months because it might be some particularly nasty water, we're able to get 12 years and counting. So we can add, that's a huge value proposition whenever you're looking at that, particularly if these are offshore pipes where the access is difficult. Just to read from the slides, which is not ideal, but fire water pipes, riser pipes, produced water, crude oil, a variety of different service. That condensate is something that can be a bad actor. There's a lot of areas where pipelining makes sense. The first step with pipelining, typically it's when they are replacing something, they want to go back with something that they don't want to replace so often, is we'll kind of have a negotiation with the mechanical engineer. Piping engineers are taught to reduce the number of flanges to a minimum because it's an integrity issue. But we need access for these. We need to be able to access for coding and for QA/QC. So I get a set of ISOs. I'll go through and mark them up. And I am knowledgeable that the more flanges, the more expensive this thing's going to be. So I'll look at what we can actually do. We mark them up with the flanges. We send it back to the mechanical engineer. But before we even go for pricing, and then we negotiate. Sometimes on the ISOs, I don't know where the structural members are. I don't know where intersections are. So we may have to figure out other ways to skin the cat. Surface preparation, we have a pipe blaster for 8-inch to 48-inch. So this goes on a winch. It pulls back just like our pipe sprayer, which I'm going to talk about in the next slide. Has 3 heads. It rotates and it blasts on the internal of the pipe. This is made by our sister company, Agmec. And then commercially available, on smaller pipes, we use the hollow blast. This uses ricochet. So you have a cone-shaped apparatus at the beginning. You blast onto it, and then it ricochets into the center of the pipe. You pull it back or push it in. In certain situations, we've partnered with technology providers throughout the world. We can put these pipe blasters and pipe sprayers on robots. There's some really, really cool technology out there if time and money permit. So the pipe sprayer is what we use primarily if we're doing pipes in situ, and oftentimes also in the shop, depending on the pipe geometry. The pipe sprayer operates off of a standard airless pump. You pump the coating through the hose. The coating goes into a cup. There's actually no spray tip, like generally you'd see somebody with a spray tip. It just goes to the cup. There's 2 motors on here. There's a motor on the end, and then there's a motor on the head. They spin simultaneously. These motors are very delicate. They're encased, but they're actually used in the dentist industry sometimes. It's a specialized equipment we're talking about here. It distributes the coating centripetally, and now you have the pipe. I do have a little video. The finish isn't great. This is an 8-inch pipe. I use the standard pipe sprayer, which goes from 8 to 48 inches. I think when we did this, our mini pipe sprayer was down, so we had to use that. But the efficacy is there. You can see it's pulled back by a constant speed winch. The idea is before you go, you have to get the flow rate correct, so the amount of flow going and then also the speed at which the winch operates, and that's how you vary the thickness and get it consistent. It's angled at 30 degrees, as you saw. That's to mimic a spray pattern. If it was spraying perpendicular, then you would risk having a shadowing effect that welds. So it's important for this equipment to be correct. We created it for this project. The offshore provider in 1989 had a problem that was going to cause them a lot of pain to where they needed a new manifold for their crude oil, a very central part to the platform. They ordered a super duplex manifold that was an 18-month lead time. So they called Corrocoat and they said, I don't know if it's possible. Can you figure out a way to line this pipe just to get us through 18 months until the super duplex manifold gets out here? We created the pipe sprayer for this project, lined it, and then once the super duplex came in, they did an inspection. The coating was fine. It had filled in the pits. The coating was perfectly fine. So they sent that manifold to another platform, and then it stayed in place, the coating, for 24 years until they decommissioned the platform. And this is sour crude in the North Sea, so it's a relatively aggressive environment. About 4 or 5 years ago, we created a variation of the polyglass VE for use in the pipe sprayer called Fibercoat. So this utilizes fibers, and there's a really good video online. The fibers work where they cross hatch, and they will actually fill pits up to 1 inch diameter. So this is for through-wall corrosion, generally in situ. Maybe it's an underground pipe, and maybe it's under your plant. Fire water happens a lot here, or there are other process fluids. To when it was installed, no one ever thought about maintenance, and then the years go by, and then you have all this plant. So pulling it up is not really an option. This is a really good way to get you out of a jam. It'll go on at about 3 millimeters per coat. Generally, we're going to want to go on two passes so that we can get full uniform coverage. Condensate cooler catch basins. The condensate lines in given plants can be a bad actor. This is, I know none of you are at a power plant, but this is at the turbine building for a coal-fired power plant. The turbine is the money section of the plant. It's essentially a clean room. So in order to be trusted to do blasting in there, they need to be really, really sure that you're going to be able to build a good containment and have it negatively pressurized. If you have areas in your plants where you need to do that, Corrocoat have become really, really good tent builders. So we can build that containment. We can utilize equipment to have a negative airspace so that you don't have any blast abrasive that gets into the atmosphere. Some large projects. This is an outlet duct, 28-foot diameter, about 10,000 square feet. We did it in one outage. The beauty of this is they didn't want to reline it. They just wanted to sweep blast an overcoat. So you may have linings, smaller or big projects like this, that are distressed, and it's a lot of surface area, and you have limited time. You're having to deal with holes and do well repairs consistently. Maybe you don't have the time or money to reline it completely. Half measure is to sweep blast it. So you just kind of sweep blast it in SP7. That's going to expose your weak areas. It'll pop off. If there's holes, you may have a welder that works with us. We did in this project. They weld that up, and then you overcoat the whole thing. So you put a new film over a swept blast surface that has the profile. Make sense? Fabric maintenance. We utilize the Plasmid ZF for a lot of this as a starter, as a primer coat. Over the years, the Plasmid ZF has gone through multiple evolutions. It keeps getting better. Now it's NORSOC approved for splash zones, seawater immersion. It's essentially a lining that we still use as a primer because it's so surface tolerant. Pipe racks, structure. In situations like this is a petrochemical plant, they were worried about gases and gas releases, so they didn't want just a corrosion barrier. They wanted a chemical-resistant corrosion barrier as well, worried about SO2. So we used the ZF primer so that we didn't have to abrasive blast, which was frowned upon in that area. Then we went on with Corrocoat Zip E, which is more chemically resistant. And then we have a Corthane AP3 top coat as well. Same concept with firewater tanks. You know, it's a nice, pretty red picture, fitting at Qualitech. This is a coal conveyor. So a very large structure. We did this as a nested contractor over the course of 3 years, taking a bite at a time, working in consistency with the on-site scaffolding contractor. This was a situation where we did what we call a spot prime overcoat. So you pressure wash the surface to reveal any weak areas and clean it. The areas that show corrosion or maybe blisters, you use power tools. You prep that to an SP3 with a power tool, remove the corrosion deposits, put the Plasmid ZF primer on. You prime the whole thing. It essentially acts as a tack coat, and then you put a new layer of paint on. This is another half measure. It's a good fabric maintenance practice. I mean, ideally, you may not even, everything's close enough here in Point Lisa's, you may not even have to have a container on site or a facility on site. Qualitech could probably do that sort of work out of this facility or one of their many facilities. We can use the AR3, we can use the ZF in addition to a multitude of different Corrocoat cuttings that cross-polymerize. Again, this is something we gave them a 5-year warranty on. It had sulfuric acid dripping down and eating away the galvanized structure. We were able to do that despite only being able to use sanding as a surface preparation measure. In fact, we didn't use the ZF here. For galvanized, we have a sister coating of the ZF called Plasmate Z-Galv, which is just it gets really good adhesion to galvanized surfaces. We can use the ZF using a proprietary method that was proven in Vietnam about 12 years ago, 15 years ago, something like that. We're an actively sweating gas line. We can spray it and get good adhesion. We had a time to first maintenance of 9 years, despite them not taking it down in Vietnam, which is a tropical climate as well. And spraying that coating on, it actually cures while it's sweating, and it protects the pipe for a long, long time. I know taking your gas lines down is never ideal, but having corrosion eat a hole in it is even worse. So that might be an application that you'd be interested in. We're kind of on the cutting edge here. There's a company in Jacksonville who are making spray painting drones. You may have seen the spray painting soft washes where they go up with the drone and they can wash. They make that as well. But now they have a spray painting drone. I've known them for 10 years. It's Jacksonville. It's a major U.S. city, but it's not that big. When they came out with this, being that we're a coating manufacturer in town, we've started to work with them to test out our Plasmate ZF to be sprayed with the drone. We're probably at about 95%. We're almost out of the beta stage. I haven't bought one yet. We can work with them to do contracting work. It works really, really well out of the drone. The ZF is ideal because surface preparation is difficult. If you can imagine the amount of pressure associated with sandblasting out of a drone, you got to one step at a time. But the ZF works, and it can work really well with this because it's surface tolerant. You can see the control here. The beauty of the drone that they've developed is the software. It's so easy a director can do it. They let me fly it, and I spray painted it. It has automatic controls to account for the wind. It keeps it away from the surface at a certain point. It's really, really impressive technology. They've used they also have a drone that'll do NDT testing. So that, if you think about the amount of control that you need you're 120 feet away to go and do an NDT test, that's how sophisticated this technology is. Here's a video. We did, on a previous iteration, we had little plates up there so that we could then take down with a high reach and test. We were getting quite the range, but we were getting anywhere from 6 to 12 mils DFT on these plates. And that's going on just multiple passes. As you can see here, you can see the drone, and we're cleaning out the tip. That's just standard practice when you're doing any kind of coating. Plasmate ZF aerosol. I told you I'd get back to it. So this is a good product. One of the major oil and gas companies, they got tired of having their inspectors go around the platforms, take a picture. A lot of times rope access, they take a picture of some spot corrosion. Then they go back to their office and they write a report. And then there's a work order. And then the next day somebody goes out and they have to break down a kit and they put a little bit of coating on this little spot, waste 95% of the kit, now you have all that waste. So they said, can you make this Plasmate ZF a 2-part surface tolerant coating in an aerosol? They asked me about it and I kind of laughed and I said, probably not. A little did I know they had already had this conversation in England and we were working on it, almost done. So the idea is you shake it up, get the ball moving. That mixes the base. I mean, standard practice, if you had coating in a bucket, you got to mix the base first because there's settlement. There's a lot of heavy solids in here. So you get that base mixing. You pull this off. There's a little key ring in here. Essentially works like a grenade. So you stick the key ring in a hole on the bottom. You pull the pin. When you pull the pin, it activates a blade. You turn it. That blade cuts a little bag of activator inside. And that's how you have a 2-part epoxy in an aerosol can. It works really, really well for spot corrosion. So now when those inspectors are going around, they have one of these in their backpack, or they have it in their pocket. You can even pre-mix it. Because it's pressurized, the pot life on this is 12 hours. So in the morning, they're shaking cans. They know they're going to see some corrosion. And then they go around, and when they see something, they probably have a scraper in their pocket, depending on how much surface preparation they're willing to do. And then they deal with it. The downfall is improper training. So what we've done is we've created a user guide so that you can classify the severity of the corrosion into multiple different levels. If it's more severe, you might use a backpack and use a bristle blaster and power tools. We've even created small little 8-ounce kits of chlorid, which reduce the chlorides. But you take that corrosion deposit off, you either do one coat to get about 7 mils DFT. That'll get you, in offshore environments, about a year. That's enough to deal with it before you go back and blast and paint the block. If you, Shell actually tested it to death, like Shell likes to do, to where if you use power tools to get an SP10, a near white blast using a bristle blaster, you can get 5 years. So if you do proper preparation, this can be more than just a temporary fix. And again, just like we were talking about the crevice corrosion, the corrosion problems that cause the most problems are the small areas. Now, you can see a big tank in a lot of corrosion. It's the things that you don't see or that you ignore that cause more headache. This is from an Oxy platform, I think, to where you see this. It's difficult to access. Rope access comes down. They do the prep, and then they use the aerosols. Really, really good way to utilize the technology. Qualitech stocks them. We would prefer to go out there and do it ourselves. But in some cases, you don't want to hire a contractor to do 10 spots that big. You'd rather do it with your own staff. So it's a good way to deal with corrosion. Concrete. So we talked about concrete in some of the Q&A before. Sulfuric acid. This is one of my first inquiries 16 years ago. I went out there and I looked at this. You can't tell, but this is just mush. I mean, it went straight down to the sub-base. We had to take all that out. We used epoxy polymer concrete to fill in the cavity underneath this pump base. The reason why I use the polymer concrete, other than it being more corrosion resistant, is that you can overcoat it with a compatible coating. You don't have to wait 28 days like you would with concrete. And then we coated it with the AR3 the plasmid AR3 98% sulfuric acid resistant coating. More on the polymer concrete. In areas around a tank, maybe you've had chemical corrosion, and I mean, this tank was actually corroding from the outside in because whenever they had excursions, it was a black liquor, it was a tall oil area, so black liquor was getting under the tank and corroding it from the outside in. So they had a couple of choices. One choice was to tear out the concrete. To replace it with concrete, you need 4 inches. So that's a lot of jackhammer and a lot of tearing it out. Or you could use a material that could be primed, and then, or you prime it and then you can apply it at a 1/2 inch. So the minimum thickness of the EPC is a 1/2 inch. You can do a lot with that material. It's chemical resistant, and then you can go on with a more chemically resistant top coat. Use it for tank bases here. Some customers, like phosphate mines, they have so much corrosion problems on their concrete, they just want a polymer concrete pump base. They just take the concrete completely out of it. We can do that with epoxy, vinyl ester, polyester. The resin systems can be matched the given service. Another cool application, at the interface of the steel and concrete in areas, you've probably seen a lot of columns that start to be eaten out like that. That can be a problem. It's a reliability problem. And if it's left unchecked, it can be a safety problem. Prime it with a ZF, form it up, put some epoxy polymer concrete, never worry about it again. More concrete. This utilizes a product called Zippy Screed. Zippy Screed can go down to about 80 mils. So when you may use the epoxy polymer concrete to get the really thick stuff, and then you can use the Zippy Screed at the smaller pits, and then also to grade to drain. So you get to that drain in concrete, you definitely want the chemicals to flow into the drain. All too often I've seen inquiries, and the drain is the highest thing in the whole containment. Not ideal. It's strong enough to deal with unloading pads. This is a HCl secondary containment and an unloading pad. So this sees a truck every day, 5 years and counting. I mean, we are starting to see some of the fiberglass pop up. It's just a quick little fix. Everything's not going to last forever. The idea is to add value to make sense for the investment. We're given 5 years warranty on sulfuric acid, secondary containments. There is a commercial side to that, of course. Nothing's for free. But if you're looking at reliability, if you're dealing with concrete issues or corrosion issues that you have to continue to deal with, eventually somebody's going to say, let's just bite the bullet and do it right. Competitive bid situations can be more expensive than they're worth in some cases. And then U-drains. It's not my men's favorite thing, but if you have U-drains in a D-min area or deionized water or any chemical plant, you probably have problems where those U-drains are leaking into the earth. U-drains are particularly difficult because they're designed to catch water. Coatings don't like water, so it takes some experience and logistics and different puddle pumps. We build temporary dams and we move water where we need to move it, and we get in and we use composite materials to solve the problem. So, how to work with us? We're on the home stretch. If you have a problem that you either don't know how to deal with, or maybe you've been trying to solve for a while, contact Qualitech. We're going to go through, we have a form, but a lot of times it can just start with a site visit or a conversation and or an email. We're going to gather all the data associated with that project. Cindy's going to send it to me. I'm usually going to send it to leads to the head office once I gather all the information. We go through that technical services and that inquiry process to get the spec right. If we have a spec, usually we do, but sometimes there's more value in the nose. When we have the spec, we'll provide a price. It can either just be a specification that you're going to put in your bid. It can be a budget price because you're at an early stage and we do it all, so we can give you a budget price. Or it can be a quote whenever you're ready to buy. We execute. We inspect on regular intervals as needed. And then you can go back to worrying about other stuff. Corrosion shouldn't be at the top of your mind whenever you're in. There's a lot of other things to worry about as an engineer. We let us handle the corrosion problems. So that's it. Corrocoat are specialists. We partner with Qualitech. We can do some amazing things for your worst corrosion problems. I appreciate your time and attention. Any questions? Yeah.
Hi, morning. So, oftentimes you have coating repairs, right? And you have the issue of, be it exchangers or piping or anything, that may have a coating system. But let's say, because of whatever age of the asset, that original system might not be available. In terms of this product or this coating system, the compatibility in terms of existing coatings, how compatible is it with, for instance, if you may have a primer layer already there, and you may need to put on, let's say, the intermediate epoxy or top coat? That's the question.
Generally very compatible. It's going to be a case-by-case basis. If you have a primer layer, you have an existing coating that's already polymerized, so it's outside of its overcoating window, then no matter what coating you use, even if it's the same coating, you're going to need a physical bond. So it's a matter of surface preparation. We've overcoated loads of different coatings, and it works really well. The risk there that we would share in that case is if that existing coating had poor adhesion and peels off, there's nothing we can do about that. But you know, if you have a lot of surface area and you feel like most of it's fine, I want to protect it. Yeah, like that project where I showed with the coal conveyor, that's essentially what that was. We went over an existing coating for most of that surface. Yeah.
Thanks.
Anything else? I know it was a long talk on corrosion. Yes.
Yes, for me, one of the properties on the Corrocoat type coatings, especially around mainly glass-flake type, right? Edge retention. So we have a lot of coating failures that really generate from edges, or the coatings tend to pull away while applied. How well, or are there any tests done on edge retention for glass-flake?
Yes, yeah. So I mean, we do really, really well with creep, I think is what you're talking about, and then edge retention maybe at a knife edge or an angle. At the welds and the knife edges, one is more of a practical. You want to go through and stripe coat that with a brush first. And then as far as edge retention and creep, where you want to have something that doesn't pull away in a sheet, that has to do with adhesion values. We get really, really good adhesion values. Most of our adhesion tests fail as a glue test whenever you do a pull-off test because we haven't found a glue that will actually pull the coating off. So you're looking at 2,000 plus PSI. Where you have creep, it's because you have poor adhesion, and that could be a result of poor surface preparation or coating properties. Yes. But yeah, I have tests. I'll have to talk to R&D. I can forward it on. I'll forward it through Qualitech. We'll give you the data. We have loads of data. We can share some of it.
Josh, I had one. You remember the slide you had with the glass flakes?
Yes.
I think it would be good to go back there and explain the aspect ratio in terms of how they fall and actually fall parallel in the resin for everybody's benefit.
Yeah, no problem. Yeah, I've done this presentation enough and variations to where it's more of an ad lib. Some aspects and stories make different ones and some don't. Yeah, a lot of slides. I appreciate y'all's attention. Yeah, so right here. Yeah, I mean, aspect ratio. So that's the ratio of the thickness to the surface area. So for instance, this has a given aspect ratio, the thickness to the surface area. This has a greater aspect ratio. It's thinner versus the surface area. If I were to drop both of these 1,000 times, there's a high likelihood that a certain percentage of those, this guy is going to line up like this, or maybe like this if you're in a film like the glass flake and the coating. Whereas if you have a perpendicular force on a high aspect ratio glass flake or anything that's flat, like a piece of paper, for instance, it's going to want to stay flat and parallel to the substrate. This is really, really important when you're looking at barrier properties to glass flake coatings. When you use lesser glass flakes, those glass flakes have a chance to wick, and then they're just not going to give you the same tortuous path. The idea with the tortuous path, and this works the same as if you, mouse problems again. So if you don't have a thick enough coating for the given surface, we specify that based on the surface, or if the glass flakes are such that to where they don't give you enough of a path, you're not going to stop the flow of the corrosion-causing ions. They're going to get to the bottom, they're going to start corroding, and you're going to end up with a bubble over a given amount of time. That's the key reason why Corrocoat started making their own glass, is that it's that important. You see, there's no ISO standard for glass flake coatings that says that it must have a certain performance value. I wish it did. We should look at performance-based properties. So there's a lot of coatings out there that say they're glass flake, but they can take just a little glass flake and do one of these in there and call it a glass flake coating. And it may or may not have the same performance value as a well-engineered glass flake coating with high aspect ratio thin glass flakes. Make sense? Yeah, I kind of breezed over that earlier. Thanks, Deepak. Anything else? Everybody hungry? Time for a coffee?
Yeah, well, if we have any more questions from anyone, don't feel shy. It's a very small, closed group here, so you can feel confident. Yeah.
So one of the popular glass flakes coatings in Trinidad among the customers is the polyflake. So how does the Corrocoat stack up against polyflake?
Full magnitude better. The last time I compared the data sheets.
Okay.
Yeah. So I mean, we'll do much. We'll outperform that, and then you'll also have a partner who's been trained, who can do that and take full responsibility for the product. Yeah.
Thank you.
Yeah. Well, I'm happy to take the Pepsi challenge with them any day.
Okay, great. Thanks.
So I have two questions. My first one is, since we're speaking about the aspect ratio, we have any data in terms of a factor that we are also improving the strength of the base material, or is that something that we have not really compared to something that is being lined? My second question is with regards to FRP piping. Instead of only using it for refurbishment works or for repairs, have we considered application as a preventative means to protect the FRP piping from degrading with UV?
Yes, that's a good application of the Corrocoat because the UV will degrade the resin over time and expose the layers. These coatings are highly UV resistant. The resins, similar resins, they don't chalk like an epoxy when you're looking at the unsaturated ester, but the glass flakes actually reflect the light. So yeah, you could make your existing FRP pipe last much longer by prepping the surface and then coating it. And there's adhesion promoters that we can use for FRP pipes that may or may not require sandblasting, which is always preferable. So we can get really good adhesion with these adhesion promoters and put a barrier coat on top of that. As far as the strength, I think you're probably referring to tensile strength. Yes, I had an inquiry similar to that when we're looking at doing multiple mile-long internal lining using pigging techniques. That didn't make the presentation. And there are benefits, but we have not been able to effectively quantify that benefit. So yes, but I can't prove it.
And I think as we get more into Corrocoat in Trinidad, you'd realize that is an engineered solution. It's not that we are trying to, just sell a coating. Many of the examples Josh would have given, you'd have seen where it's way more than, single-digit years, not 2 years, we give 5 years, 10 years. And it really stands up because of the amount of effort we put into the fact-finding. So Josh always uses the analogy of, you go to a doctor, and you get like 10 questions asked before you get something prescribed. So that's exactly what we try to do as well. It's not that we're just going to give you something to use immediately. A lot of fact-finding because we want whatever application you have to be successful.
Yeah, well put.
There's
got to be one more out there. Yeah. Well, I think we have box lunches, right? Yeah, so we'll be around.
We have some refreshments, so we could casually chat about anything you guys want. So just before we go, I just wanted to introduce you to Cindy Singh, our manager of industrial projects. Cindy will be handling most of the inquiries with Corrocoat together with her colleague Kamiraj Ramphal. So he's our in-house superintendent as well as NIST Level 1 inspector. So he's out there on the jobs. And as I mentioned before, Cindy and Ramphal would have done the training themselves for 3 weeks in England. So it's a really intensive process for them. So they understand all the products properly and also how to apply them, more importantly. Oh, we have a QR code on the wall here. You could scan it if you want to get her contact, but we'll send out an email. Most of you, if you would have registered on the Google form, we'll just send out a thank you email and it will have the contact information there as well. Also, the reason we have, all this gear around the cameras, the microphone, we would have recorded the session on YouTube. So we're going to put this link on our Qualitech YouTube channel. So therefore, you have other colleagues that you think it might be beneficial for, even friends in industry. You could just send them the link and they'll have this entire thing, the presentation, Josh's commentary, because sometimes you send a presentation, you don't really know what you're looking at until it's explained. So Josh's commentary as well as the questions and everything will be there as well. Ali, I don't know if you had any online questions. No? Okay, all right, good. All right, well, yeah, so thank you very much, everyone, and feel free to stick around. We have some refreshments for you guys. Thanks so much.
Thank you.